everyone. For this activity, you're going to read or listen to the article below and then answer each analysis question. Tree rings. Scientists use a variety of methods to collect data about the Earth's weather and climate. Weather stations, balloons, buoys, and satellites help researchers gather information about Earth's current weather conditions. Scientists learn about Earth's climate in the past by studying historical records as well as clues that remain in rocks, ice, trees, corals, and fossils. These clues not only tell us how the Earth's climate has changed, but they can also help scientists understand why these changes came about. Knowing how the Earth's climate has changed over time can help scientists determine whether the changes that are occurring now are part of the Earth's natural pattern or caused by human activities. One way scientists are learning about past climate is by studying tree rings. This field of research is known as dendrochronology. Scientists can use tree rings to measure the age of a tree and learn more about the local climatic conditions the tree experienced during its lifetime. In temperate areas, like most of the United States, trees only grow during the part of the year called the growing season. The length of this growing season depends on the climate in a particular location. During each growing season, the trunk of the tree grows thicker, producing a layer of new wood called a tree ring. It's possible to see the boundary between one ring and the next because of differences in the color of the wood. Early in the growing season, trees grow relatively quickly and produce less dense, paler wood. Near the end of the growing season, they produce more dense, darker wood. Trees generally grow more during wetter growing seasons with favorable temperatures, forming wider rings. Narrow rings may be caused by stressful periods such as droughts. Although tree rings only record conditions during the growing season, in other words, not during the winter in most of the United States, droughts can build up over many months or even many years, so a lack of rain or snow in the winter can lead to poor growing conditions in the spring. Tree ring patterns provide information about precipitation and other conditions during the time the tree was alive. Scientists can learn even more about precipitation and temperature patterns by studying certain chemicals in the wood. Modern trees can be interesting to compare with local measurements. For example, temperature and precipitation measurements from the nearest weather station. Very old trees can be even more interesting because they offer clues about what the climate was like before measurements were recorded. In most places, daily weather records have only been kept for the last 100 to 150 years. Thus, to learn about the climate hundreds to thousands of years ago, scientists need to use other sources such as trees, corals, and ice cores, which are layers of ice drilled out of a glacier or ice sheet mostly in Greenland and Antarctica. By studying tree rings and other clues in our environment, scientists have learned that there have been times when most of the planet was covered in ice, and there have also been much warmer periods. In general, climate changes prior to the start of the Industrial Revolution in the 1700s can be explained by natural causes such as changes in solar energy and volcanic eruptions. Recent climate changes, however, cannot be explained by natural causes alone. Instead, human activities are very likely responsible. Tree rings alone cannot tell us whether human activities are responsible, but they do help by revealing patterns that scientists can investigate further. Trees generally grow more during winter growing seasons with favorable temperatures, forming wider rings. Narrow rings may be caused by stressful periods such as droughts. Although tree rings only record conditions during the growing season, droughts can build up over many months or even many years, so a lack of rain or snow in the winter can lead to poor growing conditions in the spring. Because tree rings are sensitive to local climate conditions such as precipitation and temperature, they give scientists some information about an area's past local climate or microclimate. For example, rings generally grow wider in warm, wet years and thinner in cold, dry years. When faced with extremely stressful or unfavorable conditions, a tree might hardly grow at all. Then you see tree A right here. It says narrow rings do not only signify a lack of sun or water. A forest fire may have damaged the tree's crown and slowed its growth. Defoliation by insects or fungi can have the same effect. After several years, this tree gained strength and returned to normal growth. This tree had a rough time during its first 10 years and grew very slowly. It probably was not receiving enough sunlight. Later on, someone helped it by cutting the large trees around it to give it more light. This tree doesn't have its heartwood in the right place. It shows off-center growth. If the tree was in a location exposed to high winds, its wood would grow faster, which would have wider rings, on the side away from the wind than on the side facing the wind. So here are the analysis questions. You're going to use the images that are below to answer each question. It may help to make the images larger. So if you scroll down, you will see the images. You have Seattle, Washington. You have Boston, Massachusetts. Jackson, Mississippi. And Columbia, Missouri. Okay? So what you are going to do is for each of those 4 locations, you are going to find the number of light rings, which would be the age of the tree. The year the tree was planted, so you'll subtract the age from the year harvested, and the year harvested is on each of them. Okay? And then you will select one ring that seems to reflect above average precipitation for the growing season based on its width. Determine the corresponding year by counting the rings, starting with the youngest ring, which is closest to the bark. List the year you have selected. Okay, so you do it for all of them. And then there's 3 questions for you to answer.